Welcome to PyTorch 2021 Hackathon. My name is Hamid. I'm on partner engineering team from PyTorch at Facebook AI. My job is to help ML developers like you to improve their solutions with PyTorch using its best and greatest features. I'm also one of the co-maintainers of TorchServe. Today, I'm excited to tell you about TorchServe and give you some example of how it works, so you have a better idea on how you can use it in the hackathon. So during today's video, I'm going to start talking about model serving. Then I will have a quick overview of TorchServe and walk you through how to use it. Finally, I will end with the demo so you can see it in action. What is model serving? You have trained your model, and now we have to integrate it into a larger system to make it available for running inferences. I'll be using the term model serving to refer to this integration and the subsequent use of the model. TorchServe is the native model serving solution for PyTorch. It's a performant and a scalable tool for wrapping your PyTorch model in an HTTP or HTTPS API. In this short video, I won't be going into advanced features of TorchServe. Instead, I'll focus on the stuff that you need for the hackathon, namely how to install your TorchServe and start serving inferences from your model. First step is to choose your handler. This can be a default handler that TorchServe provides out of the box, or your custom handler. Handler in TorchServe is a Python script that includes all your model initialization, pre-processing, inference, and post-processing code. We already have out-of-the-box handler for a number of applications like image classification, segmentation, object detection, and text classification. And you always can write your own handler that fits your need. This can be especially helpful in cases where you are using a pre-trained model from a third-party library, such as Hugging Face or others. As you can see on the right-hand side, you can simply initialize your model and apply your custom logic for any of the pre-processing, inference, and post-processing steps using the four main functions here. After you choose your handler, second step is to bundle your model and all supporting files that it requires into a model archive that is a MAR file in TorchServe, and place it in the model store that TorchServe can see it. Next step is to start TorchServe and configuring it for serving your model using the TorchServe Inference API. Management API will give you the control to register, unregister, scale up or down the number of workers for your model. And finally, when to find the logs so you can see what's happening under the hood. If you participated last year and saw TorchServe tutorial, then you will notice that we have added several examples, including Hugging Face transformers and MMF models, which is a multimodality framework from Facebook AI research that allows you to combine signals from different modalities. We also have added Ensemble support, where you can define sequential or parallel pipelines with several examples to help you get started easily. TorchServe now has a new explanation API powered by Captom that provides insights about your model outputs on different levels. I encourage you to have a look at Captom library on captom.ai. Also, if you are a Kubeflow user, TorchServe now has integrations into Kubeflow Pipeline, KF Serving, and Google Vertex AI. If you are using MLflow as your MLOps library, TorchServe has been integrated as a deployment plugin with different examples that would make it easy for you to get started. TorchServe overall has grown in multiple areas. Along with the new features, many performance optimizations has been applied to it. This may not affect you if you are a first-time TorchServe user, but if you are more advanced, you will want to be aware of this. I have included a bunch of examples here. If you are interested in checking them out, I will add the links in the comment section of this video. If you are a cloud user and architecturing your solution, TorchServe has integrated into different services on major cloud providers, namely AWS, Google Cloud, and Azure. I've included more examples here. Check out the comment section of this video for the links. Before going to the demo, I wanted to mention that TorchServe is in production with companies including Matroid, Toyota Research Institute, and Wadhwani AI, serving models for different use cases from computer vision to NLP. Another example of a team using TorchServe is Dynabench, a research platform within Facebook AI for dynamic data collection and benchmarking. If you follow ML competitions in the space, you might know Flores, a low-resource language competition. Flores is running on Dynabench, which uses TorchServe. Please check TorchServe GitHub repo for more details and examples at github.com/pytorch/serve. Now we are going to switch to the demo part. Now we are in the demo section. First, let's make sure that we are in an environment with PyTorch 1.5 or higher, that we are using 1.1, which is the 1.9, which is the latest version, and we need OpenJDK 11, version 11 of Java Development Kit. And if we have these two, we can install TorchServe along with Model and Workflow Archiver. Workflow Archiver recently has been added to support ensembles. We can install TorchServe using pip or Anaconda, and I'm using pip here. Now TorchServe is installed. For this demo, I'm going to use an image classification example from ResNet and using this example from TorchServe repo. You can find this example in github.com/pytorch/serve under examples. And here I'm going to break down the steps for you. The example uses a pre-trained ResNet 18 model from Torch Vision. I'm showing this example as transfer learning is very popular in the ML space these days. Here I'll show you how this works, how you can extend it in your case, and if you are using a pre-trained model with TorchServe, how you can serve your models. You are going to access the model through Torch Vision models, and if you want to fine-tune the model based on your data and the task that you are working, you can use it here. In TorchServe, we can serve the models in both eager mode, and alternatively, we can TorchScript your model and use the TorchScript mode. PyTorch recommends TorchScripting for deploying your models, especially in production setting. TorchScripting models gives you an intermediate representation of your model that it can run in a Python-free environment. This will bring a good speed up for your inferences. This is an optional step and part of the performance optimization recommendations. To learn more about PyTorch model and performance optimization offerings, you can check pytorch.org/tutorials. I'm going to save the model weights here, and we are going to use the eager mode for this presentation. Now we are going to create an archived file, which is a single file that bundles your model checkpoints along with all the supporting files that it needs. In case of NLP, it can be a vocabulary file or an index file to make the result of the predictions more human readable. I'm going to use this command. Important things to notice here are the name of the archived file, the version flag that specifies the version of your model, as TorchServe simultaneously can serve multiple instances of the same model for A/B testing or benchmarking purposes. Then we have the model file flag that you can specify the model class definition. We are using the model class definition provided by the example, which basically borrows the ResNet 18 definition from Torch Vision. Then we have the serialized file flag that let you specify the model weights, the handler flag that let you specify the handler. Here we are using a default handler in TorchServe for image classifications. But if you have your custom handler, you can point it to the path of the handler here. Extra file flag will let you to add the supporting files to the model archiver that here in this case we are using index to make the predictions more human readable. And if we run this command, it's going to create the .mar file for us. This is the archive file that we made now. We have used the Python, we have used the model weights, the model definition, and the index to archive the file and make the model. Now we are going to make a model store and move the archived file to the model store. Next, we want to start TorchServe, and we are gonna use this command here. Again, important things here to notice is the start flag for TorchServe. Then with the model store, we are specifying the path to the model store where our archived file lives. Then with the models flag, we can specify the name to the API endpoint and also the archived file that is gonna use. And at the end, we have the NCS flag that stands for no configuration snapshot. By default, TorchServe saves its state as a snapshot that next time that you restart it, it will restore the snapshot. For the purpose of this demo, I'm gonna turn it off. Now we are gonna start TorchServe. We can see that the logs are scrolling, the model threads are set, and we can see that the worker threads are set here. Then the model has been loaded into the memory and it's ready to serve the inferences. Now I'm going to switch to another terminal and start to query the general status of the TorchServe. I'm going to send a request to the management API to check the status of the TorchServe, and generally by default port 8080 is assigned for the management API. Now it shows us the model name and the model URL that basically is the archived file that we specified. And if we want to learn more about the details of the file of the model which is being serving, we can add the model name to the URL, and then it will show all the details for us. That we can see the model version along with the runtime, the number of workers, batch size, and all the details about the model that is being served. Next, we want to pass an input to run the actual inference. And for this, we are gonna use port 8080, which is basically assigned for the predictions API, and we assign the model for serving our inference. Then we are assigning the model input as well. And here we can see that the result of the model inference are top 5 predictions from the model. And basically, we also have the explanation API that can provide the insights about your model outputs. I'm not going to go through it here, but I encourage you to look at the examples in the repo to learn more about it. Next, we want to stop TorchServe, and we can simply call TorchServe from command line with the stop flag. And now TorchServe is stopped. To check your logs, you can basically check the logs directory that has been added to your folder. And if you see, you can see that it has different logs about the access to the model server, the model log, the TorchServe logs, and TorchServe metrics. And basically, if you're running into any issue, model logs would be a first good place to look at. Before we finish this demo, I want to skim through an NLP example that uses a custom handler to serve the popular Hugging Face transformers. The example lives here in Hugging Face transformers under example in TorchServe repo. The main point I want to show you here is that you can write a custom handler, which is a simple Python script that initializes your model and places all the processing and pre-processing and post-processing code in one place. This will bypass the need of providing the model class definition explicitly to the model archiver. Here, in this example, We initialize the model and tokenizer from transformers, and you can see that all the pre-processing and post-processing code goes into one place in this handler. Another important thing that I want to highlight here is that all the extra files that you have passed to the model archiver are accessible here. TorchServe extracts the archived file in a temporary directory, and now you can access all the files that you have bundled here in the handler. And then you can use them in your custom logic as needed. I highly encourage you to check these and other examples in TorchServe repo for more use cases. So now that you know what TorchServe is and how it works, you should have everything you need to get started with TorchServe in Hackathon. Feel free to reach out to us with any questions, suggestions, or feedback by opening an issue on TorchServe GitHub repo. Thanks so much for joining us today. Good luck on the Hackathon.